Hello everyone, this is Wilson. Welcome back to my 1 minute presentation. Today, I'm going to continue to talk about the carbon monoxide distribution in smoldering fire. And today I will focus on how the CO yield will affect the carbon monoxide movement and distribution inside the compound. So I have set the different CO yield in the FDS to match the experimental results. So 0.2 CO yield in our FDS simulation, the smoldering fire, the gas released from the smoldering fires are only set as the carbon monoxide and the carbon dioxide. So if we set the CO yield as 0.2, for example, so there we'll have 0.2 CO and 0.8 carbon dioxide released from the surface. So let's take a look to the result. So for the CO yield smaller than 0.15, so just look at the green curve, 0.12. So in the beginning, if the trend and the shape of the curve are matched with the experimental results, which is the black one. But in the later simulation, the 0.12 CO yield with carbon monoxide concentration will drop. So why? This is because the weight of the gas will become heavier when the simulation times is become longer, as there has so many carbon dioxide released from the surface. As we know, the carbon dioxide weight is heavier than the carbon monoxide. So for the 0.15 CO lower than 0.15 CO yield, the weight of the gas will become heavier so that it cannot sustain the trend of the experiment. So let's take a look to a 0.15 to 0.2 range of CO yield. Each match with the experimental result. So in the simulation, there is different CO concentration distribution within the models. So as you can see, the shape of the curves are showing a increasing tendency result, and which is matched with the experimental curve. Also, the peak CO concentration also are similar to the experimental result. The error is acceptable. This is because the smoldering phenomena is very uncertain in the real life, so it is acceptable. So 0.15 to 0.2 CO yield is matched with the experimental result. For the CO yield larger than 0.2, maybe 0.25 for example, the peak CO concentration are far above the experimental result. That means if the CO yield larger than 0.2, it cannot match with the experimental result. So this is the end of my presentation.